Okay, welcome back. We're on page 390 talking about memory. Now, memory is very fast, but it's very expensive. So we often have both primary storage and secondary storage for a reason. And I mean, wouldn't it be kind of cool if I had a machine that had all RAM and no hard drives? That'd be kind of cool, wouldn't you think? And I don't have enough money for that, but it could work. Okay. So the only thing that the operating system actually talks to is memory. Nobody else gets to talk to memory, not directly. So that's the only thing that the CPU can talk to directly is that memory part. Now, I mentioned to you this thing called swapping. Well, there's another concept that's closely related. It's called virtual memory. And that means I don't really have enough physical memory to pull this off. So I'm going to do some swapperoos. And I'm going to, instead of waiting for me to get in a memory constrained environment and start swapping things out, I'm just going to go ahead and tell you that this is the amount of memory that you have. But I'm going to go ahead and extend it out here a little bit more. And this will be permanent. It'll always be there. And that part is going to be just a part that goes onto your hard drive. So I've actually taken the amount of physical memory that you have, extended it a little bit, and that part gets stuck onto a hard drive. Now, if it's not being used, that's great. If it is being used, then it swaps it in and out, in and out, in and out, over and over again. But unlike the other, where you're waiting for some condition for it to be swapped out, this is always there. So if you tell it how much you got, it's there forever. Cool. So the operating system responsibilities, that's kind of a common theme in this. I'm talking about all these components, and the key part to remember, hint, 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 is what's the operating system responsible for. So in this case, it's responsible for allocating memory to the users, right? Some user application says, I need a megabyte of RAM, and the operating system says, well, hang on a second. Ding! Okay, here, you can have that. So, asking for memory, because then later on, as the process is running, he goes, dang, I need a little bit more. And so your operating system says, well, okay. Goes down and grabs a little bit more and hands it to them. So the initial request and future requests are going up or down. Returning memory to the pool. So if I have that application stops or quits or dies or exits, well, then whatever memory was being used gets returned back to the pool for some other people to use. That's pretty cool. And of course, the other thing is, from a security point of view, I want to make sure that this application over here can't peek at things that are going on over here. So the amount of memory that's been allocated to this machine is its alone. And over here, this machine has allocated memory that's it's alone, and they do not see each other's chunk of memory. It's like they all have their own little piece. Data stores on page 391. So now we are talking about things like hard drives. Okay, so this is secondary storage, hard drives. And so hard drives are you might think, man, hard drives are fast. Well, compared to memory, no, they're not. They're actually pretty doggone slow, but they're cheap. And so they have an example in the book. I have an updated example, but you can buy a 1 terabyte hard drive today for about $50. They're kind of cheap. You might not be able to find that in a retail store, but if you go online, yeah, you can find a terabyte drive for $50. However, if I wanted to buy a terabyte amount of RAM, not that my machine has enough slots, this is purely hypothetical, but if I wanted to buy a terabyte of DD4 RAM to fit in my machine, it cost me over $5,000. So, $50, $5,000. I think I'm going to go for the 50, wouldn't you? Yeah. So, yes, these things are kind of sort of slow, but they're dirt cheap when compared to RAM. Okay. They talk about removable media, and you know what all this stuff is. You talk about floppy drives, if you guys have ever even seen a floppy drive. CDs, DVDs, Blu-ray discs, USB flash drives, things of that nature. Tape drive, I'm sure no one's seen a tape drive before. So those are things that just, pop in and out of your system. You don't install them and leave them. They're removable media. Okay, cool. The next thing to talk about is the file system. So inside this little hard drive, I actually have to have some sort of structure, order to it, so that the operating system can make sense of what's on here. I can't just have hodgepodge of stuff. The operating system basically has to create some order here. And it's typically done through what's called a file system. And the file system is something that happens when you format the drive. So when I format my disk for the first time, it puts the file system on the hard drive. So now when I ask for a particular file, it knows there's going to be a folder structure, and under the folder structure is a file and some additional folders. And this file system knows, what is the maximum length for a folder and what's the maximum size for a file. It has all these rules and regulations that you have to follow. So that's one of the things that it does. Is tries to, it has to impose some sort of order onto the system. And then the operating system, now that it has an order, operating system says, wait a minute, you don't have read permission on that file, or you don't have write permission on that file. So it's all about, so the operating system's responsibility, that common thread, operating system responsibilities for files has to do with what kind of permissions do you have? Do you have read permission? Do you have write permission? Those kinds of things. Cool. So the operating system is responsible for creating files and deleting files and reading and writing, and only the operating system is allowed to create a file. User applications can't do that anymore. So if I want to create a file or read a file, I got to go through the operating system to pull that off, and that's where the permissions things happen. Okay. The next thing to talk about on page 391 is the operating system security. Now, we've already talked about it in several times about, user isolation and permissions on the files and things of that nature. So we're just going to keep going down that path. So almost all operating systems are multi-user, right? You could have multiple people either on at the same time. That would be cool. Or even if you just logged out and then your kids logged on using another account. That's multi-user, right? I've got more than one user on a computer. And so the machines keep track of if they were both logged on at the same time. The machine keeps track of, what games are being run over here versus what word processing is being run over here. They're all, that user silo thing where essentially the machine, as far as you know, there's nobody else on the machine. It's 100% yours because that's all you get to see. So it keeps all that stuff separate. There's a term called domain separation, which kind of sort of talks about this in a little bit more detail. And that is, it separates the user mode from the kernel mode. And we talked about there's a kind of an imaginary line that goes split right through this operating system block, where the kernel mode and the user mode. And make sure that none of these things actually go back and forth unless they go through a gatekeeper. So there's the gatekeeper that goes between the user mode and kernel mode, and the gatekeeper is the operating system. Okay, cool. So that an errant user app, let's say I've got a user app over here, and I'm in the user mode, and it completely craps out. I mean, big time. Blows up. Corrupts memory, everything. Well, maybe even, messes up. Blows up big time. It's probably not going to take the operating system down. Now, I don't know if you guys remember back in the Windows 95 days, Windows 95 and Windows 98, there was a possibility that if you had an application that you were running on in your user space, that when it died, it could take the whole machine down. It could crater the whole machine. The machine would reboot. That's pretty doggone rare now because all these things are separated, and there's no way that a user application can actually get to that part of the machine to mess it up. You might mess up your own stuff, but you're not going to mess up the rest of the computer. Okay, so domain separation. The other is process isolation. I just mentioned that processes being run by this user are separate from each other, and processes from this user are separate from similar processes of another user. So each process is isolated, and for the exact same reasons. So if a process goes crazy, it won't affect all the rest of the processes. Cool. There's another term in here. They talk about resource encapsulation. That's a mouthful. Better way of describing it would have been abstraction. And the idea is that I don't have to have I don't have to know exactly what brand mouse you have, or what brand keyboard that you have, or what brand hard drive you have. All that's done abstracted for me. So the operating system basically says all keyboard behave like this, all mice behave like this, all hard drives behave like this. And so therefore all you need to do is ask me for where's my mouse position, where are the keys, and how do I store things on files. You don't have to know what brand or model is in there. And the idea is, behind abstraction is, so my mouse is getting a little funky, so I just go to the store and buy another mouse. So I don't even have to shut down the machine, right? I could just unplug my mouse, the old one, take the new one, plug the new one in. It may say, ding dong, I detected a new device. I'm up and running. I mean, I didn't have to go into the operating system and tell it anything because it's all abstracted away. Likewise, if I shut the machine down and added a new hard drive, the machine would come up and say, hey, I see a new hard drive. I didn't have to tell it what kind it was, and I could swap out hard drives all day long, and I'd be okay. So this whole point of abstraction. So the operating system provides basically like a shortcut or an abstraction. It's kind of I'm using those same terms over again. I'm struggling to come up with a better term. Basically a shortcut. So when an application wants to be able to read a key from the keyboard, it basically just goes to the operating system and says, hey, how do I read a key from the keyboard? And the operating says, don't worry about it. I'll take care of that for you. And then it goes off and does its magic and says, here's what the guy pressed on the keyboard. Anyway, it's called an Application Programming Interface, an API. And so all operating systems have APIs. And the APIs include things like, how do I get a key from the keyboard? Something simple like that. Okay. The other thing that APIs do, before an API will allow you to like delete a file, it's going to say, the API itself is going to say, now wait a minute, who are you and what kind of permissions do you have? So, I mentioned that all that happened. Now I'm telling you where it happens. The API calls themselves check for, before they go do something, they actually check for the permissions. Okay. There's a concept in the security world called the least privilege. A concept of least privilege is the way I usually hear it. All right. And so the idea is users should be granted only enough permission to do whatever it is the application requires them to do, and no more. You should never give them more permissions than they need. The concept of least privilege. So, as an example, an ordinary user on a machine can't install a new application. And trust me, if you work in a corporate environment, that's a good thing, because people are crazy, and they'll bring stuff from home and try to install it on your corporate machine, and God only knows where it came from or whether or not it's infected. So ordinary users don't have permission. So if I'm writing an application, I don't ever want to grant to that person the permissions to install software. That would be really, really bad. So the idea is give them only the amount they need and no more. Okay. In the Windows world, this is called whenever you run across one of those scenarios like we just described of installing software, it's called user account control. There's a little prompt that pops up and says, say, I see that you are an administrator, but you're doing something that requires administrator rights. Are you sure? And so you go, yeah, when you hit the button. Or you could say, no, I did that by accident. I'm sorry. Okay. This is a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.